Hello, beautiful people. Welcome to 3.3 Graphing Systems of Linear Inequalities. Materials you're going to need, probably a pencil. If you have a highlighter, that'd be cool, or colored pencils, that'd be nice as well, and ruler. That should do it for us. So really quickly, definition. A solution to a system of inequalities is an ordered pair that is a solution to each inequality in the system. Because these are inequalities, there's going to be a lot. So we're going to be doing some shading, hence the this, hence the highlighters, or even if you have just a different colored ink, I think we'll be doing pretty well with that. So if you need to press pause to grab those things, I would go ahead and do that. Otherwise, 2 steps for graphing. Number 1, graph each inequality as we would for any line. And then number 2, we're going to do some shading in the region that's common to all of them. So my tip for these, when we're talking about y, if it's less than, we're going to shade below. If it's greater than, we're going to shade above. Kind of makes sense. If we're talking about x, if it's greater than, we're going to shade regions to the right. And if it's less than, just like on a number line, the numbers that are to the left would be shaded for less than. Okay, so we have 2 lines right now. The first one that I'm looking at is x is greater than -3. So for x, would it be horizontal or would it be vertical? Hopefully you remember that this would be a vertical line. So here's my vertical line and it's at -1, 2, 3. So I'm going to go ahead and draw that in. Oh, and I just messed up because we need to also differentiate a couple things as well. Whenever it is not equal to, just like when you're graphing on a regular number line, remember how if it wasn't equal to, we would have an open circle, but if it was equal to, we would have a closed. Similarly for these ones, if it doesn't have the equal to sign, instead of an open circle, we do a dashed line. Dashed line. Right there at -3. Can you see it? There you go. So if you need to, you can kind of go through. Because it's on a line, it's a little bit hard to see. So I like to make it a little bit thick. There we go. So now the next thing is this is greater than. So if I'm talking about the x, the vertical line here, greater than is everything to the right of -3. So I'm going to shade, but I'm not going to go too heavy with my shade. Okay, then you're going to do the same thing, but with the other line that you have there, which is y is less than or equal to 2. I'm going for markers here instead of pencils. I don't know if you noticed that I switched. So this is going to be a horizontal line, and this one's going to be solid because the equal to line, equal to sign. Nice and thick so we can all see it. This is where you need to kind of write out loud and be super duper bold. Now this is less than, so I'm going to shade below. And when I shade, I'm kind of going to shade in a different direction just so that my eye can see. Now, looks a little bit like a mess. Here's what I need you to make sure, like for sure, number 1, I want to make sure that your boundaries are super duper bold, like they stand out in a crowd. And then number 2, I want to make sure that I can tell, even from a distance, where your double shaded area is. So one way to do that is just take a highlighter and highlight that area. Now if you don't have a highlighter, then you're just going to take your pencil and then go super duper bold in that area instead. And that's how we graph these. So that was with a vertical and a horizontal line. Let's try some that are a little bit more nifty. So first thing that I need to do when I'm graphing, I'll start with this one, is isolate the y. So I'm going to go for slope-intercept form. You could find the intercepts, but I think that the shading part gets a little bit more complicated than what I would like for it to be if you do that. Not that you can't, it's just I wouldn't. So subtract 2x on both sides. 3y is less than -2x plus 6. Divide by 3, divide by 3, divide by 3. I do divide each term by 3 just to make sure that I get every single term. So -2 over 3x plus 2. I believe we can graph that. So I'm going to start at 2, 1, 2, and put a dot. And then I'm going to go down 1, 2, right 1, 2, 3. Down 1, 2, right 1, 2, 3. And I'm also going to make sure that you can see what I'm doing there. And you can already tell my dots are a little bit hard to see. But when I connect them, my question for you is, would it be solid or would it be dashed? And if you said that it would be dashed, you are correct because it does not have the equal to sign there. So I'm going to dash it up. New terminology for you. I'm going bold. I actually changed my mind from what I said in the beginning. Instead of a pencil, have like a thick marker or a Sharpie or something, just because teach you what you need to know for life, beautiful people. You got to be very, very clear about what your boundaries are. So this is y is less than. For less than, I'm going to shade below. And I don't need to go dark, so I'm going to use my pencil for that. Shaded less than, golden. Now, if you could, let's look at this one. 2x plus y is less than or equal to 2. I will subtract 2x from both sides, and I get y is less than or equal to negative 2x. That's a negative 2x there, and it looks low-key, high-key, sloppy, plus 2. So I'm going to start at 2 again. What a coinkydink, does not matter. And then I'm going to go down 2, right 1. Down 2, right 1. Sorry. Now, my question for you is, would this be a solid or dashed line? Solid or dashed? Correct. Solid. And I gave you a little Dora flashback there. So I've connected it. Now, my question is, for this line, should I shade above or should I shade below? Well, let's look at it. This one says it's less than or equal to. Less than is going to be below the line, right there. Boom. Looks like a mess. I can't really tell what the double shaded area is at first sight, so I'm just going to go ahead and wherever I see the pencil in the red for me, the double shaded area, that is my solution. Being careful of what? Boundaries, beautiful people. Boundaries. Don't cross them. There you go. Do you love it? I do. Kind of my favorite graphs to do here. Alright, let's try another one, just like the other one. Now we're stepping up our game just a little bit, and I'm going to give you 1, 2, 3, 4 of these to graph. Could be complicated, but it's not really. You're still just graphing lines. But what people don't like is it feels like it's kind of messy. So you want to kind of just really keep track of what you're shading and where you're shading it. Shall we begin? The first one, if you could, go ahead, press pause. Actually, you don't have to. I know you know how to do this. So x minus y is greater than or equal to 0. When I get y by itself, I'm going to minus x. Negative y is greater than or equal to negative x. I'm going to literally divide by negative 1. And when I do that, beautiful people, please do not forget to switch your arrow. Cool. So here I go. Here is 0. I'm going to go up 1, right 1, up 1, right 1. Notice at this point I stopped labeling the M and the B. You can take a moment and do that if you need to. I'm just a little bit advanced, you know. So you can say that the M is equal to 1 over 1 and the B is 0, 0. I feel like we're kind of past that point in our relationship, so I stopped doing it. Solid or dashed? Solid, because it's equal to, and I'm thick right here with the bold, heavy line here. So boom, boom. Now it's less than. So I'm going to go in here and I'm going to shade everything less than or below that line. Now if you're having a hard time with that, like how did you know? How come this isn't less than? Well, 1, it's above the line. But 2, you can pick a point. So if I pick this point, 1, 0. If I'm right, then when I plug 1, 0, 1, 0 into the original equation, this is my x, this is my y. I would say 0 is less than or equal to the x, which is 1. Is that true? Yeah, I'm right every day, all day. Not really. I make mistakes, but I just got really confident because I like this part of our lesson. The next one, guys, is right here. So x plus y is greater than or equal to 0, so minus x. And I have y is greater than or equal to negative x. So I'm going to start at 0, and I'm going to go down 1, right 1. So it's going to be like we have an x, down 1, right 1, down 1, right 1. Super duper clear still with my boundaries, and I'm going to ask you again, would this line be solid or dashed? If you said dashed, you are right again. So now, as I shade, I'm going for the area above this. So here's my line, just to make sure we remember. Here was my line. I want to go above it because it's greater than. So here I am. Also helpful if you just do different cross patterns, because right now I'm looking at the part that has like the little X part in there. Got a couple other lines here. I have X less than or equal to 3. I know that because it's just an X and because there's 4 V's in the X saying vertical, 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 vertical. I just drew it there, but you couldn't see it. This will be my line, and where will it be at 3? 1, 2, 3. Solid or dashed? Well, it's another solid line. That's not as fun. Less than. This is getting tighter. You guys feel it? Do you feel the pressure? I'm going to go for my red pen now. And I'm focusing on the triple area. And right now my triple area seems to be this whole part right here. Triple area has the cross pattern and it has the red. So kind of have that in your mind. Right now I'm looking at this triangle. And then for my last line, y is less than 2. So here's 2. It's horizontal because it's just the y. Solid or dashed? Less than, not equal to, solid. Just kidding. Dashed. Too confident. 1. There we go. I do want it to be really thick because it is super dashed. So boom. Alright, I can see my boundaries for all 4 lines. Hopefully you can see yours as well. Now my next question is less than this. Less than. Oh my gatos, what a mess. But I knew that I was in this one, and I know that I'm less than that new horizontal line. So just go up to the horizontal line and then shade. Bam. There you go. You survived 4 inequalities on one graph. One more example for you all. I'll probably let you do some graphing on your own as I'm running out of time. The babysitting club has a budget of $90 for pizza. Oh, for a pizza party. The club can get large pizzas for $10. That's nice. And cases of soda for $3.50. The club would like to buy at least 5 large pizzas and at least 3 cases of soda. So we have some constraints here, which are kind of important. Letter A, write a system of linear equations, or inequalities, excuse me, for the information. They're telling us already, they've defined my variables. Use X for the number of large pizzas and use Y for the number of cases of soda that the club will buy. So the first one, we've got some money constraints here. We have a budget of $90. So whatever I buy has to be less than or equal to 90 bucks. Well, what am I buying? I'm going to spend $10 for every pizza, what they say, X, plus I'm going to spend $3.50 for every Y. Cool. What else do I know? Well, I know that I want to buy at least 5 large pizzas. So X needs to be greater than or equal to 5. Maybe otherwise I don't get my discount. Oh, sorry guys. And then I know that I want to buy at least greater than or equal to 3 for the Y. Cool. Those are my 3 things. I feel like you know how to graph this and you know how to graph this. Let's graph this one and see how we do. Do I really want to get Y by itself? I really don't. I think I really, in real life, well, let's just emphasize something else. Let's find my, I just kind of want to find the intercepts instead for this one. Yeah, I'm going to find the intercept. So the x-intercept happens when y equals 0. So I plug in y equals 0 and I get 10x is less than or equal to, actually we're solving here, so 90. So the x-intercept is 9. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. Do the same thing really quickly with the y-intercept. Press pause right now. Okay, so I did that and I got y equals 25.7. You can press pause and copy my work if you need to. And I went by 3's and I graphed it right about there and then I connected the dots. It has to be less than or equal to that. So in my mind I'm thinking, okay, it's got to be under budget. We want to be under budget. Take a moment please and graph these 2 lines as well, but don't forget we changed the scales to go by 3. So this one's going to be bam right there instead. So check your graph, make sure it matches mine, and then for the final part, give two possibilities. Well, one possibility is 6 pizzas and 4 cases of soda. It's anything that's in this region, so it could be 7 and